Board fabs may cut around the board shape using different technologies, ranging from routing to sawing or V-cuts. The most common method is routing, but the board designer doesn't know the diameter of the tool used by the fab. Best practice is to use thin lines on the outline layer to draw the shape of the finished board. The common interpretation is that the centre line of this line will be the edge of the finished board. It is not the name of the layer but the properties of the layer group that matters. The board outline is specified on a global boundary layer group. For internal cutouts, sometimes also called slots, use the slot layers. Normally the edges of a cutout shouldn't be plated, which makes the slot unplated layer the appropriate choice. In case of cutouts, or mechanical layers, the layer group is global mech, with the purpose being P root or U root, depending on whether it's plated or unplated. The board has two rectangular cutouts now, one plated, one unplated. Outline and cutout shapes should be drawn using lines and arcs and never polygons. The endpoints of adjacent lines and arcs must be perfectly aligned. A properly chosen grid can help with that. Drilled holes are specified from pad stacks, vias and pins. The pad stack prototype has a flag indicating whether the hole is plated or not. Unplated holes are indicated with a red circular mark in the hole. Both in the case of holes and cutouts, plated and unplated features are exported to different files. However, many fabs ignore this and decide whether to plate holes based on heuristics, such as whether the hole touches copper on the bottom and top layers. An oval slot for the tab of a connector is typically made as a pad stack. The pad stack is constructed from lines drawn on the plated slot layer and one or more copper layers.